Hey everybody, this is Larry. This is day 11 of the Leetcode Daily Challenge. Hope, yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. And of course, Happy New Year, Happy Chinese New Year, Lunar New Year, wherever you want to call it. Um, yeah, let's take a look at today's poem. Today's poem is 1463, Cherry Pickup 2. I remember this one actually. Uh, I remember this one not for a good reason. I remember this one because I remember this one on a contest where I misunderstood some of the inputs or something like that, and it cost me like a finish on the contest. Like I had to, I think the wrong answers during the contest, and I would have been like maybe top 10 or something weird. I forget what it is exactly, but I still remember this one as a result because I forget how I thought about it. But I thought that was unclear whether the robot starts at the exact corner, giving this image, or at the cell above this, which is shown in this image, kind of, depending on how you want to think about it. But all right, that's actually. But I don't remember the problem, so let's take a look. You're given rows and columns. Okay. You have two robots. One starts at the upper left, and the other's upper right, and then you want to collect cherries. Okay, so this is going to be dynamic programming. The way that I'm going to attack this problem is recursively. There are kind of things we have to do with this problem, so we'll kind of talk about it as we code, right? But let's start with the really basic, naive dynamic programming, memorization, or just really not even before that, just a very basic recursion, right? Well, and the very basic recursion you can say is just where the robot X is and the robot Y is, right? So then you have maybe, let's just say calculate, or what was it, get max maybe? Get max, robot AX, AY, BX, BY, right? Something like that. And then, you do and of course, if you, and I don't know that I'm going to write this out, but the naive way to think about it is going to be, you move, maybe you move X, maybe you move, maybe you move robot A and then robot B or something like that, maybe at the same time. And then, so what is the problem here, right? The problem is that there are a lot of states. One is that there are a lot of states. We have AX, AY, and I'm just looking at the constraints real quick. I think it's like 70 by 70. Yeah, so then now you have 4 dimensions. Each of them could be 70, and 70 to the 4th is going to be me pulling out a calculator. Hang on, right? That's already 24 million, and each of them has like 3 moves or something like that. That's already gonna be too much. 600 million. Not to mention anything else, is already gonna be too many things to calculate for, in my opinion, right? So let's see if we can do a little bit better. Not to mention that there are actually, even if you do it that way, it's a little bit tricky because you have to keep track of cells that they have taken, right? Because if they both take, or for example, in this example 1, they both cannot take the middle 5. Okay, actually you can't really see my mouse, but like on the second row you can both take 5, because if they both in the same place, then you only get the benefit once, right? So that's no bueno, because you have to kind of remember all the states. So what is a better way of thinking about it? The better way to thinking about it is just that, for the Y dimension, we don't have to do them separately, right? We could just simulate them at the same time. And that's basically the core part about this part, is that you could, which one is Y? I guess, sorry, I think I confused X and the Y, but basically X is going to be the thing, and then Y being the column is just what column robot 1 is and what column robot 2 is. And that should be good enough, because it allows us to kind of, one is reduce the number of states. Now we have 70 to the 3rd power states, obviously a good thing. And then the other thing is that it allows us to keep track of things that we've seen before, right, by the other robot, because everything on the on top of whatever we're calculating now, we've already calculated, we've already seen it, we've already done everything, so we're all Gucci. We don't have to think about it anymore. So then now we don't have to worry about storing more knowledge, storing more states and stuff like that. And that's pretty much it. to kind of get started. This is still going to be a little bit tricky. What is 70 to the third anyway? Right? Is 243,000, and you have 9 directions to go, for 3 for each one of the robots, and that should be pretty straightforward. All right, so here, we can think about base case. If x is equal to r, then maybe we can just return 0, because then we're done. Otherwise, the current score is going to be grid of x ay plus grid of x by, right? If ay is equal to by, then score is, I don't know, equal to grid of x ay. Doesn't matter, right? Just one thing. Okay, and then now we can brute force, the 3-dimension, right? So dA, maybe you want to say, in range of, range, just go left, right, or left, down, right, and then dB is going to be also the same thing. Right, and then now, this is the current score, and then you have the best. It's going to be, say, just, I guess, score, the current score. But yeah, best is equal to max, best of get max. So x plus 1, we move on to the next row, and then ay plus dA, by plus dB. And that's basically it, right? Maybe I'm off by some stuff here and or there, but yeah. And then this is c-1, right? Of course, there are some minor things we have to clean up. For example, we have to make sure that ay plus dA is in between the columns, right? And also the same thing for by plus dB, right? Oops. But yeah, did I mess it up? I mean, probably. Oh, I just did this thing, but then it should be so it's this thing plus score, right? Yeah, so it looks good. It should be Gucci, and yeah, it handles everything, and that's pretty much it. And now all we have to do is just add the memorization as we usually do. So yeah, we have and that, yeah, this was a hard problem once upon a time. I think I did okay during the con, except for, I don't know, misreading it for some reason, which made me very sad. But yeah, and there are additional, so there are a couple of optimizations that, I don't know why I think I just did this on autopilot, to be honest. This is actually 3-dimensional, obviously. So right. Okay. Yeah. Right. Sorry. There are a couple of optimizations that we can do. The first one, of course, is converting it to bottoms up. It is actually, I think this one is relatively straightforward if you're practiced. If you're not practiced, then definitely advocate practicing converting this problem going bottom up. And once you do that, you can make a space optimization on this one as well, because you can see that each row only depend on the previous row. So you already kind of eliminate one dimension, and then that's pretty much the idea. Yeah, 12 day streak. We did the contest earlier today, so I'm just gonna call it a night. But yeah, that's what I have for this one. Let me know what you think. Yeah, what is the complexity? I don't know. But yeah, but this is going, like I said though, I already did the complexity a little bit, right? So number of inputs is going to be R times C, and each input takes all of 9 times, right? Which is obviously all of 1. So this is just going to be in total R times C, time and space as well, right? And that's pretty much all I have for this one. Let me know what you think. Yeah. Maybe, I don't know if I'm going a little bit too fast today. Let me know if I'm going a little bit too fast, and leave me know in the comments, or you could watch my older video and let me know, because I mean, I'm not gonna lie. Sometimes it's a little bit weird because I look back and I'm like, I have 4 videos. Oh, this is my 4th video, and you're like, I don't know. Am I learning anything? Are you learning anything? I don't know. I always try to teach a little bit new, a little bit different, but at a certain point, I don't know that I am anymore, to be frank. So yeah, I mean, this looks pretty much the same thing as I have now. So anyway, yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy to your mental health. Happy holidays, everyone. I'll see y'all later and take care. Bye bye.